with respect to B. Okay, now what is the order of reaction? What's the definition for that? Well, it's fairly simple actually. The order of reaction is defined as what it is in that rate equation. So I'll dictate it for you. The order of reaction is the power to which the concentration term is raised in the rate equation. So the order of reaction for a particular substance is the power to which the concentration term is raised in the rate equation. The power to which the concentration term is raised in the rate equation. So, how did I get this? How did I get this as my rate equation? Well, I had to do an experiment. So, do an experiment. You do an experiment and you find out your results, and your results tell you what the order of reaction is. And it's fairly straightforward, because all you do is you say, right, let's look and see. If I change the concentration of a substance, what happens to the rate? Okay. Well, if I change the concentration and the rate remains constant, then what's happening there?
It's order zero.
It's order zero. So it's order 0. Now you can say even more about that, of course, because you can say, you now know that if it's order 0, i.e. changing concentration does not change the rate at all, you know it has no effect on the rate of reaction, and therefore it has no effect on the rate determining step. So it's definitely not going to be in the rate determining step, that particular substance. So in my example here, I can say A is not in the rate determining step. So I'm already starting to be able to construct a reaction mechanism, because that's another thing we need to be able to do, from the information I've got here. So if I find that concentration has no effect on rate, I know it's 0 order. What happens if I find that concentration and rate are directly proportional?
Order 1. First order.
1. Or first order, if you prefer. Order 1 or first order. And the only other scenario you're going to come across is if you have order 2, in which case you see an exponential increase, order 2 or second order. Both of those expressions are used. Okay, so is everyone with me so far? Because we're doing pretty well here. We're going to finish quite soon. Okay, because there's not much more to this. But, so, what we do, remember, is we take a chemical reaction, we've got our chemical reaction, and we do an experiment. We change the concentrations of our reactants, and from this data that we get, we find that we can determine the order of reaction. So what effect those things have on the overall rate of reaction, and therefore we can construct our rate equation. Yeah? Everyone happy with that? Now you also sometimes see graphs which are sketched like this, and you will see that if you have, say, time, and you have concentration of a particular substance, let's call it X, concentration of X. Now if you have the change in concentration of X with time is a straight line going down like that, then that is 0 order. And notice the axes are different here. This is the change in rate with the concentration of a particular substance. But if we're looking at a particular substance in a chemical reaction, and we're looking at how that concentration changes with time, then we find, and if it's a straight line, it's 0 order. What do we find if it's first order? Yeah. Now, what sort of curve is it? Okay. It's okay. The key thing I'm looking for here is that the half-lives are constant. You know about that?
Yeah.
Don't forget that T1/2 is constant. So the half-life is constant. Now, what do I mean? Well, all I mean is if you take the concentration at let's say the concentration for that graph starts at 1 molar, and then you take the concentration at 0.5 molar, you measure the time it takes to get, and that's supposing it's 25 seconds. And then you take the concentration at 0.5 and you take the concentration at 0.25, because that's half, the concentration is halved again, and you measure the time it takes to get from 0.5 to 0.25, and you find it's 24 seconds. And then you take it from 0.25 to 0.125, 0.0125, no, 0.125, and that's halved again, and you find it's 25 seconds again. Then within experimental error, of course, 25, 24, 25, within experimental error, those half-lives are constant, yes, and therefore you know it's a first order with respect to that particular substance, X. Okay. Now, it'll look like that if it's second order, and for second order, T half is not constant. Okay. So it'll look like, so here you've got a straight line for zero order, here you've got a nice neat curve here, for first order with constant half-lives. Here you'll have a much sharper curve, and the half-lives will not be constant. Do you follow that? So that's another important thing for you to be able to understand, because a lot of these kinetics questions are based on experimental data. So you're given experimental data and you're asked to plot graphs, and then you have to explain, and that is quite commonly that crops up about half-life. Okay. Now equally, quite commonly, in fact, I would say more than quite commonly, in every single paper I've ever seen so far, there is a question which gives you a set of data, and it says, here is the concentration of A, and you know, I think you know what I mean already, do you? Yeah. It says, right, you've got a table, it says concentration of A, concentration of B, and then it says rate. And what you do is you just look, and it says, okay, concentration of A was 0.1, concentration of B was 0.1. When I double the concentration of A, sometimes they do something really irritating, like changing B at the same time, which is a bit annoying. But let's suppose again that they don't for the first one. And then they say that the value of rate here was 2, and the value of rate here, when I doubled that, I made that, well, if I made that 4, it's nice and easy, isn't it? That's the sort of thing you get. And you look at the data and you say, hang on a minute, if I double the concentration of A, what happens to the rate? The rate doubles. Well, of course, that corresponds to this here, this relationship, directly proportional relationship. A directly proportional relationship, if I double the concentration, I double the rate. That means it's first order, of course. Yes? But if I double A, and what will happen to the rate if it's second order? It'll be 8. Yes. It will be 8. Now, why will it be 8? Well, the reason is because if the rate is equal to K times A times A, now that's what second order is, isn't it? A squared is A times A, yes? And of course what it means is the effect is happening twice. So I'm doubling the rate. When I double the concentration of A, I'm doubling the rate once. And then also I'm doubling the concentration of A twice, so I'm doubling the rate twice. And that's why that second order has that effect of quadrupling the rate, because it's an effect of doubling twice. We don't write it like that, but that's what's happening. So A squared, if you double that, okay, alternatively you can just say, well, you take the value of 0.2 and you square it, well, that's going to have twice the effect on the rate. Okay. Do you follow that? Maybe. Anyway, basically, if you double the concentration, just to summarise, this is the graph. Remember, every single exam I've seen one of these appear somewhere.
This is the second.
Okay, a table of data. Please don't talk. Please don't, because it's really annoying. It's so annoying. I hope some of you become teachers. So you've got the table, or do some teaching at least at some point in your lives. So you've got your table, and remember the table of data, just look, it's very simple. You look and you see, if you double the concentration and the rate doubles, it's first order. If you double the concentration, it has no effect on the rate, it's zero order. If you double the concentration and the rate multiplies by 4, yes, then you know it's second order. Now hang on a second, because just quickly, if I triple the concentration and the rate triples, it's first order, yes? If I triple the concentration and it's second order, what will happen to the rate?
9 times.
It'll be 9 times, that's right.